Hey, Pat.
Hey, Michael, how you doing?
I'm doing well. Hello, everyone out in the live stream. If you're here live, super happy to have you here. Put some comments into the live chat and we'll try to make them part of your show. If you're listening later, thanks for watching and being here on YouTube. And with that said, I think it's time for us to kick it off. Pat, welcome to Talk Python to Me.
Thank you. I'm so honored to be here. Longtime listener.
Oh, that's fantastic. I really, really appreciate that. It's an honor to have you here. We're talking about one of these subjects that I really enjoy. I feel like it's one of these more evergreen type of topics. You know, it's super fun to talk about the new features in Flask 2.0, but that's only relevant for so long and for so many people. But writing software that's reliable, that can be changed over time, doing so in a Pythonic way, that's good stuff to learn no matter where you are in your career.
Oh, I absolutely agree.
Yeah. So you've written a book called Robust Python, which caught my interest. I, as you can imagine, get a couple of books and ideas sent to me periodically per day. And so they don't usually appeal to me, but this one really does for the reasons that I exactly stated in the opening. And we're just going to sort of riff on this more broad idea of what is robust Python? What is clean code? Like, how do you do this in Python and make it maintainable for both you in the future and other people and so on?
Yeah, sounds good.
Yeah. Before we get to that, though, let's start with you. What's your story? How do you get into programming in Python?
So I got into programming like many males my age. I loved video games as a kid. And I was 12 or 13, and some ad in one of my video game magazines caught my eye for a video game creator studio.
Oh,
and
nice.
It was this C++, C++ engine, but it provided easy ways to do sprites and animations and particle effects. And they gave you step-by-step instructions. Here's how you build Pong. Here's how you build Frogger, and here are the assets. And I started riffing on it. I really came to love it. I then took a programming class in high school, True Basic, which I don't remember much of other than I don't think I'd ever go back to it now. But it interested me enough that I decided to go into computer science in college. I learned more about the video game industry, especially some of the hours they work, and said, you know what, maybe the video game industry is not for me, but I still loved programming at its heart. So I continued on and just found a few jobs after college and just went from there. As far as Python went, so I worked in telecom for a little bit.
Okay.
And early 2010s, we had some test software. It was all written in the Tcl programming language.
Mm-hmm.
And that is an interesting programming language. As far as types go, everything's treated as a string. And it led to some very unmaintainable code. So a few sharp engineers and myself, we decided, what would it look like if we wrote this in Python? And a whole test suite automation was born from there. And we just went, wow, nice. Python makes everything nicer. Like, this is so much pleasurable to work with. And I've done like C++ and Java before then. So Python was this breath of fresh air, and I just fell in love with the language.
Yeah, those are both very syntax symbol heavy languages. I've done a ton of C++. I did professional C++ development for a while. I've never done much Java, but yeah, they're really interesting. I remember when I came to Python, I came from C#, but also from C++. And just in my mind, those symbols, all the parentheses on the if statements and the semicolons at the end of the line and all that business, that was just required. That's just what languages needed to be. And then they weren't there. And I'm like, I'm having a hard time with this, right? And I felt it was weird. But then when I went back just to work on like a project that was still ongoing, it seemed more weird. I'm like, wait a minute. My eye, like the wool's been taken off my eyes. I know now these are not required, and still here I am continuing to write them. And it just drove me crazy once I realized I don't have to put these things here. It's just this language that makes me. And so, it was really nice.
Yeah. Python kind of captured that magic for me. And it's funny because going back to C++, every once in a while, my C++ got a lot better because of Python. You start focusing on the simple. That's nice.
Yeah, exactly. You're not trying to flex with your double pointers and all that kind of stuff. It's like, we don't need this. Let's not do this. Come on. Very cool. So how about now? What are you doing?
So right now I am a software engineer at Canonical. I'm on their public cloud team. So we're building the Ubuntu operating system for public clouds,
Awesome.
AWS, Azure, GCE, a couple others. And so we customize the images for clouds, work with a lot of other canonical teams to make sure that their changes are reflected in our software. And we maintain the CI/CD pipelines to deliver those as often as we can. Most of the tooling is written in Python, so I get to use Python day to day, which makes me happy.
Oh, that's really cool. What kind of features are we talking about here?
General hardware enablement. So, clouds may have new instances, new processor types, working to make sure that that's enabled. Do a lot of close work with our kernel team. Features that the cloud themselves might request, maybe,
like something the cloud needs to set up and maintain the VM aspect of it.
Yep.
Okay.
More on the infrastructure side. Maybe how do they hibernate their VMs?
Okay.
How do they improve boot speed? Those sort of changes. How do they improve the security profile? That's something I'm working on right now with some of our clouds.
Yeah, super important, right?
Yep.
That's part of the promise of going to the cloud is often there's better security and better durability. But if it fails, like it fails for potentially all of some big chunk of the internet, right? Like that's the consequence of failure is also higher. So
you have to be very aware of how many people are using your software when you deploy to the cloud.
Does it make you nervous to work on that kind of stuff?
Oh, absolutely.
Yeah.
I'd be lying if I said it didn't, but you learn to be careful. You learn to really focus on making everyone, having good communication between your teams, making sure there's no surprises for anyone, that sort of thing.
Yeah. I remember that as well, just working on certain things. Like the first e-commerce system I wrote, I'm like, this thing's going to be charging thousands of dollars per transaction, and I might screw this up. And I'm really worried for deploying it for the whole company. There's like big purchases people were doing. And it made me really nervous. But at the same time, one of the things I've come to learn over my career of programming is it's one of the things that will really put a sad look on your face is if you spend a lot of time and create beautiful software and no one uses it.
That's true.
Yeah. So even though it may be stressful that it's getting used a lot and it's really central, that's also amazing, right?
Yeah, but it's also made me a better programmer because you just start thinking about explicit error cases more. At my last job, I mentioned I did telecom, and it's like 911 calls get routed through your equipment. You don't want to fail that, and it is scary at first, but you learn to develop disciplines over time of, okay, how do we make sure we're not making mistakes along the way?
Yeah, absolutely. And, speaking of that, I think that's maybe a good segue in to talk about this idea of robust Python.
Yeah.
First of all, let's just talk about your book for just a minute, and then we'll just get into the general idea of it. Like, what motivated you to write this book?
So I mentioned I've done C++ development in the past. I started diving heavy into modern C++ and how it uses a lot more type safety features than some earlier versions of C++. Did a quick dabble into Haskell just from a learning perspective, and really started to love static type systems. But my day-to-day language was Python. So I really, really dove deep on, how do I make my Python safer moving forward? So I pitched to a few publishers. I want to write a book about, type system best practices in Python. Let's talk type checkers. Let's talk how to design types and so on and so forth. O'Reilly, who published my book, they bit and they said, oh, that sounds interesting. Can we expand the scope a little bit more? And I thought, okay, well, why do I write types in Python? Why do I, advocate type systems? It's to make things more maintainable, to make things live longer, to make things clearer. And the idea of robust Python came out of that.
I think it's really a pretty interesting idea. I do think when you come from these languages like C++ or Java or something, there is something to be said for it literally is verified to be clicked together, just like a perfect jigsaw puzzle.
Yeah.
Right.
It won't catch every error, but it can catch more errors, and that's a good thing.
Yeah, I remember how excited I was when I got my first non-trivial C++ thing to compile, and I'm like, yes, I've done it. Little did I know, I was in for it. It was out of compiler errors and into real errors.
Yeah,
at that point, right? But
the fun errors, right?
Yeah, exactly. The why is it seg fault, whatever. I don't know. We're gonna work on that. So anyway, that was really interesting. I do think that it's not required Right. I do think that there's really interesting code being written in Python, and you can see that how it's being adopted in all these ways. The biggest maybe example I have in mind of these two things side by side is, YouTube versus Google Video, and how Google Video was in Python with 20 engineers, Google Video was 100 C++ engineers, and eventually Google just said, all right, we're going to put that project aside and buy YouTube because they just keep outrunning us in features with Python.
Yeah, I think that's the beauty of Python is that you can build things fast, you can see them working faster, and you don't have to fight the compilers much of the way. So it's almost like these two things are at odds, and I think the answer is just Python's gradual typing. You just type as you need to. You add typing where it makes sense. And I won't be prescriptive and say you need types everywhere, but there's certain places where it makes a lot of sense and can save you money and time.
Yeah, I do find it pretty interesting how they've implemented types in Python. And to be clear, this idea of robust Python that you're focused on, types is just one part of it, but it sounds like it was the genesis of it.
It was absolutely the genesis.
Yeah. So we have sort of two other realities that we might look at. We could look at C++ or C# or Java, like they're all the same in that regard. They're like static compiled languages. And then we've got something that's much closer to Python with TypeScript, where they said, we have the same problem we have with JavaScript, which is even less typed because the runtime types are all just, weird dictionary prototype things anyway. And we want to make that reliable for larger scale software and integrations and stuff. So we create TypeScript. But the real fork in the road, I think, that was interesting is the TypeScript people said, we're going to apply the ideas of absolute strict typing. Once you start down that path, it's all down that path. And they have to match up. Whereas in Python, it's like, let's help you down this path, but not give up the zen of Python where you can easily put things together and you're not restricted by this type system. But if you run the right tools, be that PyCharm, VS Code, or MyPy or something like that, it'll be there to help you make it better in lots of ways. I think that's a really creative and interesting aspect of it.
Yeah, I absolutely agree with that. A lot of things that I discussed throughout the book is the idea that these are tools in your toolbox. And so I talk about types, I talk about API design, I talk about extensibility. They're all tools and they shouldn't be applied everywhere. I really want to start focusing on first principles. Why do we do the things we do in software engineering? And what are the most appropriate places for them?
Yeah. You had a really interesting quote in your book about software engineering. And I've always sort of struggled to have this conversation with people like, oh, are you a programmer? Are you a coder? Are you an engineer? Like, where are you on the, like, is that even a meaningful distinction? And to a large degree, I've always felt like it was just sort of, whatever sort of culture you're in, if you're in a startup, it's one thing. If you're in like a giant enterprise, they may value a different title in a different way. It's all kind of the same. But you had this cool quote that said something like, software engineering is programming integrated over time.
Yes, and I wish I could claim credit for that, but that actually came from Titus Winters of Google in a C++ con or CPP con talk. And it's just really resonated with me. We program, but software engineering is the efforts of that programming over years or decades. Your code will live decades. The more valuable it is, the longer lived it probably will be. I've worked on code that's been 15 years old when I started on it. And there's code that I wrote 12 years ago that's still running operationally. And that scares me to some degree because it's like, oh, did I know what I was doing back then? But it just reemphasized like why it's so important to think towards the future of what your audience. You're going to have maintainers that come after you. And do you want them to curse your name or do you want them to be like, oh, thank goodness, this person wrote something that I can use. It's really easy. And I always prefer the latter on that. I also like to say,
and the nicer code that you write and the more durable and long-lived code that you write, the more it can continue to have a life even after you've stepped away from the project, right? It's like, this thing is still working well. We can keep growing it rather than it's turned into a complete pile of junk that we got to throw away and start over, right? So that's a goal that you might want. And then also that long-term maintainer might be you.
Yep. Yep.
All
You
right.
might be working out 5 years from now and you go, why did I make the decisions that I did? I don't remember this. Maybe you've jumped to a different project and came back. It absolutely can be you.
Yeah, it absolutely can. So maybe let's talk about some of the core ideas that you have about making software maintainable, reliable. One of the things you talk about is the separation of time and how code has to communicate, or the artifacts that we all produce around code has to communicate with people, both maybe almost immediately, right? Like I'm working on this project with a couple of other developers and we need to like keep it going forward. The other one is like way down in the future, someone comes back and they're like, oh, I'm new here. The person who created it left. Maybe talk about some of those ideas that you've covered.
Yeah. And so it feels a little weird because what we're talking about is asynchronous communication. And it's weird to talk about that on a Python podcast and not talk about async await.
Yeah, exactly.
But there's asynchronous communication in real life, which I actually think is much harder. You have to think about, you're time traveling to some degree. You have to think about the future and you have to communicate to them. You probably will never meet them. You'll never talk to them. The only thing that lives on are the artifacts you create. So your code, your documentation, your commit messages, that's what people in the future are going to construct this mental model of your work from. They're going to be doing archaeology when things go wrong. Why is this code the way it is? Is it safe to change? What were the original intentions? And so the more you can embed that into code you write and the surrounding commit messages, documentation, the more robust your code base is going to be, the more you're communicating intent to the future.
Yeah. Well, I do believe that's one of the things that was so important for 2020, 2021 for all of us, right? Like, we didn't know how much we were going to need it because there's always been this kind of tension. Well, there's the open source world and these other projects, and there's those weird remote teams, but we come to our cubicles and we all sit down and we have our stand up in the morning and we write our software together. And like and we use, Perforce or something internal where we lock the file. No one else can edit the file till I unlock the file, right? Like there's these different ways, and we've been moving more and more towards this sort of everything. Even if the person is right next to you, the way we work is as if they were across the world. Yeah. And it's been really, I guess, lucky for us as an industry that was mostly in place.
Yes,
that actually became true.
Yeah. And so I think you touched on an interesting point of a lot of developers think, oh, if we're close in space, we can collaborate. I don't have to worry about my remote teams and I don't have to worry about, someone global. But by thinking of that, your collaborators in that terms, it sets you up to think about the future as well, because you can be asynchronous in space or asynchronous in time.
Right. And basically the same tools are there to address it.
The same strategies help with both.
Yeah. So one of the things that you talked about was this principle of least surprise.
Yeah.
Tell us about that principle.
Yeah. The principle of least surprise, also known as the principle of least astonishment. I feel like it's safe to say most developers have gone through a code base and been legitimately surprised and went, that function does that? Oh my goodness. I would never have thought that. Once worked on a nasty bug where the get event function was setting an event. And I kept overlooking it because I'm like, what's a get event? It's just a getter. I can ignore this. And like
this will have no side effect. This will be fine.
2 days later, I'm like, let me go step through this. And I was floored. I'm like, of course this explains my bug. So your goal when developing software is you don't want to surprise your future readers. And I think this is why people say avoid clever code. Favor clear code over clever code. Mm-hmm. You don't want to surprise readers. Many people may not be as well versed in the language as you. Maybe they're coming from a different language, maybe from TypeScript to Python. The more you rely on clever tricks or poor naming or just the wrong patterns, you're throwing people off their beat, and there's an added cognitive burden that they must then carry to understand what you've written.
Right. One of the beautiful things about different abstractions are, here's a function. I read the function name. That's all I need to know. Here's a class. I understand what the class does. I don't need to go and look into the details. And it lets you build these more larger building blocks of conceptual models. But if that's not true, right? Like if a getter is a setter, well, then all of a sudden those things are all out the window. and that's bad.
Yeah, I mean, we work by building mental models, and you need trust to build those mental models. And as soon as that trust is violated, it just starts taking time to do everyday tasks. You say, I want to implement a single API endpoint. Well, if I have to go dig through 10 different files just to make sure I'm doing everything right, that's going to slow me down.
Yeah.
And if I can trust that my mental model is correct, and it's been shown to be correct time and time again, I can put more faith in that code, and I can feel safer to start changing that code.
Yeah, for sure. Another thing that I really liked about some of your ideas was that you talked about people having good intentions, even if they write bad code. Like they're trying their best, and they're for the most part. I mean, there might be people who are just lazy or whatever, but for the most part, like they tried to write this well. Even if it came out bad, they probably tried to write it well, and it just didn't turn out as good as they hoped.
Yeah. And or even they wrote it well, and it's just changed over time, and those original assumptions got lost.
Right. It made sense in the early days, and the assumptions or the context changed, and now it's no longer accurate.
Yeah. Or it's inflexible, and it's really hard to use to extend to your current use case. I see that all the time.
Yeah. So one of the ideas that I thought was interesting is this idea of legacy code. And I've always been kind of fascinated with, what does legacy code mean?
Yeah.
Because legacy code for one person could be COBOL. Legacy code for another person could be Python 2.6. That's pretty old. It could even just be Python 3.6 that's been around for a while, right?
Yep.
And there's different people have different definitions. Michael Feathers has a cool book called Working Effectively, or Effectively Working with Legacy Code, something like that. It's an interesting book. I believe it comes from maybe a slightly different time, but still some of the ideas will make you think.
And I was going to quote that book, actually, because his is legacy code base is a code base that doesn't have tests. And I used to think that for a long time. And I love tests, but I've come to evolve my understanding of legacy code. And here's where the definition I've settled on. Okay. Legacy code, a legacy code base, is a code base in which you can no longer communicate to the original authors or maintainers. So the length of time doesn't matter as much. If you've lost contact from the original authors, all you have is the code base and its surrounding documentation to understand why it's doing the things it does. So that's become my favorite definition for legacy code as of late.
Yeah, I like that one too. I don't really like the tests one. I see where it comes from, but I feel like it's judging a world from like too strict of a place, right?
Yeah.
Like, because not every piece of code is written in a way that it has to be absolutely correct.
Yeah.
Right. And so I think this is also a good way to sort of scope this conversation, because a lot of times people hear, oh, I have to use protocols, and I have to use MyPy, and I have to use X, Y, and Z, and I have to do all these fancy things because Pat and Michael said so, because they were awesome. And it's a big hassle. I don't think I need it, but here I'm trying to be a good software developer, right? So I'll give you an example. Like years ago, I switched all the TalkPython stuff, especially the TalkPython training stuff, from relational databases and SQL Alchemy over to MongoDB and MongoEngine. And so I had to write a whole ton of code that would take a couple of tables and then put them into a structure and then put them in Mongo. And that was all fine and good. But here's the thing. The moment that code ran successfully, I never wanted to run it again. It only had to run once. It had to move the data one time. When it was done, there was no scenario where I cared about its typing or I cared about its continuous integration. I could have deleted it. I just kept it because, hey, source control. But like there's these scenarios, right? On the other hand, you talk about like if you're an online, reservation system, like the reservation booking engine, that part needs an entirely different bit of attention and mindset than my little migration script, right?
Yeah. And what I see is, what value are the things delivering? Some things have one-off value, and that's perfectly okay.
Yeah.
Your migration script, it served its value, but there won't be much value derived from it in the future. Right. Maybe from an archaeology standpoint of how did I go do this?
Yes,
but
exactly. Maybe.
Purpose. With something that's core to a business, a reservation booking engine, it delivers value when you've built it, but you want it to keep delivering value throughout its lifetime. And furthermore, the people who are working on it want to deliver value just as fast as you did in the beginning. So you don't want to slow down the future. You start getting into where you get product managers saying, why is this taking so long? This is super easy. Why do you have to spend 3 weeks just adding this one little field? And the answer is often, oh, we didn't think about how to enable value faster when we built it. And there's a tricky line there, because you can't just gold plate everything and say, I'm going to make everything super flexible. That often has the reverse effect. It makes things too flexible, and that becomes unmaintainable. But there's a fine line between saying, okay, I'm going to think for the future and deliver value now.
If every dependency can be replaced and everything can be configured from a file, some settings file, and like eventually that becomes a nightmare. It sounds cool. It's not cool. I've worked on some of those. Yeah, it's just painful.
And so here's the advice I give to people who want to think about how to make their code base more maintainable. Target your money makers, the things that produce value, because those are the things you want to protect in whatever value means to you. Target things with high churn. So you can look in your Git history, you can see what files change the most. Chances are those are the files that are being read the most. They're the files that people are working in the most. Putting more safeguards in those files, making them more extensible, will pay off just because more people are using them. Look for areas where you do large swaths of changes. It's called shotgun surgery, where if you want to add a single thing, you have to touch 20 files. The same 20 files keep getting changed again and again in a grouping. That tells you that, if I were someone coming in new to the project, how do I know it's 20 and not 19 or 21? That's a place we can simplify.
Those are the things that are super easy to forget a case.
Oh, yeah.
Right? Like, we added this feature, and every if statement had an else if that covered the new thing, except for that one where we did the auditing, or except for that one where we checked if they were an admin. That one. Yeah. Now everyone's an admin. Whoops.
Yep. And so that's the sort of places where I think type hinting is, and other strategies are just super useful, because you can start encoding those ideas of, I want to catch this when I miss a case. You can start encoding that into your checks, into linters, into type checkers, static analysis, and so on and so forth, which I think is important.
Yeah, absolutely. So I think people are pretty familiar with the typing system these days. I think it's really cool. The new type system is coming along with more things, like 3.9 now lets you write lowercase set bracket integers or whatever, rather than from typing import capital set, and then you can say it in parallel, right? That's really nice. With the pipe union definition, you can do like none pipe a thing instead of optional.
Yeah.
All of those are really nice, and so on. I suspect that a lot of people are using types for their editor, but are not going any further than that with anything like MyPy or continuous integration or any of those. Do you want to maybe speak to like the use case of both of those?
Yeah. So the use of editors alone is valuable. You get autocomplete. Autocomplete
gets squiggly alone, if you do it wrong.
Yeah.
That's right. Autocomplete alone is so good. And I was just thinking, when you were talking about that getter that was actually a setter, there's a really good chance that whoever wrote that code knew that was bad. And yet their tooling was such that it was so error prone for them to change the name that they were willing to live with a getter that changed values, because they're like, I could break so much stuff in ways I don't understand if I don't have like a proper set of tools, like a proper editor that'll do multi-file refactoring and continuous integration and all of those things, right? And so this is sort of like in that vein of your tools now do more for you.
Yeah. And so if you take a look at how costly errors are, an error at the customer is incredibly costly when you factor in support and testing and field engineering, whatever you need to resolve that customer context, not to mention loss of customer faith.
Yeah, but that's a big one.
It's expensive for tests in the later stages of QA to catch an error too, because now our development hasn't been planning to go fix this test or this code. We have to stop what we're doing and go back and fix this test that maybe we worked on 3 weeks ago. The best time to catch an error is immediately after you write it. And that's where that tooling comes in with your editors. As you're typing, if you can find an error, great. It is the least amount of cost you could have spent. And then the second least amount, in my opinion, is letting some sort of stack analysis tool catch it, something like MyPy. So using types, you can say, I want to encode some assumptions into my code base. This value will never be none. This value may be none. This value may be an enter string, or this string.
If you're right that it's never none, you never have to check it for none.
Right.
But if you're wrong, you always have to check it for none, right? Which is it?
Yeah, we don't want to do defensive programming of checking is none on every single variable we create in every function invocation. That would just, it wouldn't be fun. But your alternative, if you don't have that tooling, is, all right, does this function return none? Let me go look at its source code. Oh, it calls 5 other functions. Let me go look at their source code. Oh, this calls something to the database. Is that a nullable field? And anytime you're making someone trawl through your code base to try to answer a question of, can this value be none? You're wasting their time, and they're either going to delay delivering features that just adds up over time, or they're going to make some incorrect assumptions, and that's going to cause mistakes, which will lead to time and wasted money.
Yeah. You've already talked about focusing your attention to put things like type annotations on the parts that matter and not necessarily stress about the parts that don't, especially for code that's being retrofitted. But even code, absolutely. I think that's not, right? Like the thing that logs, it's going to turn whatever to a string. And if it comes out as like, some object at some address, like we'll catch it later and figure it out. But it's the core thing that you want that stuff to be right. But one of the things that can be challenging is the interest and the buy-in and the love for this idea might not be uniform across your team.
No.
And I've seen the same thing for testing, and I've seen the same thing for continuous integration, not necessarily the same person in the same thing, but it's like if there's a person on your team that just doesn't care about the continuous integration and turns off all the notifications that the continuous integration fails, and then they keep checking in stuff and failing the build, like, not again. I got to go fix this because this person doesn't bother to check their thing. And it just gets super frustrated. And I feel like probably typing has a similar analogy to that.
It does. And that's why if you're in a legacy code base or even a maintained code base that doesn't have a whole lot of typing in it, there's some alternatives you can have just beyond being strategic where you pick. There's some fantastic tooling like MonkeyType, which can annotate your code base for you. There's Google's type checker PyType. It can do type checking without type annotations, and it does it with a little bit different philosophy than MyPy, which I think is kind of cool. It tries to infer based on just the values throughout your function bodies, what the types should be without type annotations. So there might be ways to get the benefits without actually making the full commitment to those type checkers for just type annotations in general. There's also, tie real world value to it. Look through your bug reports. If you find out that, hey, we've had 12 dereferences of none in the past, month, and it's cost us X,
such attribute, whatever, right?
And it's cost us X amount of dollars. I can now go to someone and say, look, this is costing us real money and our time. Sometimes data speaks volumes. If you're having a tough time convincing people, I often say, find the data to back it up. Look through your bug reports and find out what would we have caught? How much faster could we go? How much? Do just even an informal survey around your developer base. How much more confident do you feel working in your code? And use that data to decide, yes, this is working, or no, we need to look at alternative strategies.
How much autocomplete do you get?
Yeah.
That might be a winner right there. That would for me, actually.
Yeah.
Absolutely. So I do want to move on to some other ideas because it's not all about typing, but I think typing unlocks a lot of these sort of durability ideas that you're covering there. So another one that you talked a lot about, I think is really interesting in this context, has to do with collection types and knowing the right data type, you know, and that matters so much, right? Like somebody might use a dictionary where they should have used a set or something. And you're like, well, you used a dictionary, so you mean me to look this up by value? Like, no, I just want to have one of everything. Like, well, okay, but then why do we use the dictionary? But that people, when they're new, they don't necessarily know that. They find the first thing that works. They're like, oh, a dictionary worked for this. We're using dictionaries. But beyond that, it means something for certain container types and other things, right?
And I think if you look at the Zen of Python of, there should only be one way to do it. Most people say, but there's multiple ways to do that. Like I can use a dictionary, I can use a set, I can use a list and just search for unique values. And It's
Code it in a string and you can parse it every time.
yeah. The choices you make, the abstractions you choose, communicate a certain intent. When you choose to use a set, that tells me I can iterate over it. There won't be any duplicates, and I don't. I won't be looking things up by key. When I think of a dictionary, I think of a mapping from key to value. The keys must be unique. But if all I care about is the keys and no values, like there's added cognitive just dissonance of why do I have values for this dictionary?
They're all zeros. It doesn't make sense.
Yeah, it goes back to the principle of Lisa Stochman.
Yeah.
You get surprised, like, oh, this dictionary is being used as a set. I get it now. And if you're not addressing that as you find it, you're just kicking the can onto a future maintainer who then has to add that to the 20 other things he's trying to keep track of throughout their maintenance of the program. You mentioned that one of my big pet peeves is so a dictionary, I say, is a mapping from key to value. And that's typically a homogeneous mapping. Every key is the same type and every value is the same type. But we really, really, really love dictionaries for things like JSON responses or relationships of data. And that can be so detrimental to maintainability of code bases if you're not careful. So the problem is a type checker isn't the greatest at saying, oh, this is a dict. Some of the keys are strings, others are ints, others are decimals, and the values are all over the type. You can use a types dict to try to get around that. But really what you're talking about is a relationship of data. When you talk about dictionaries, you're getting into if I see, let's say I'm code reviewing. Let me put this in concrete terms. I'm code reviewing some code, and I see someone accessing dictionary, and the key is foo. I have to go look at all of where that dictionary was created and modified to make sure that foo is actually a valid field in that dictionary. I have no guarantees just if I see dict in a type checker, a type annotation. So again, it's that trawling through the code base and, oh, this is actually coming from an API. And now I have to go read the API. And I can't effectively code review code or maintain code if I'm just reading that through without doing that every time to make sure something hasn't changed. So in this case, I say use a data class. You have explicit fields. You can lean on your tooling. If you mess up the field, you aren't expecting to see new fields get created in probably 95, 99% of the time. And I'm like, I will prefer a data class to a dictionary if I have heterogeneous data almost all the time.
Yeah, and maybe get it back like a Flask API call, call JSON, and then just jam that star that thing into the data class, something like that.
Yep, and I know you've talked about Pydantic on the show a lot. I love Pydantic. Just define a model, let it parse that JSON response, and just build that data class for me. Throw an error if it's invalid, and I really like that model of attacking programs like that.
I love Pydantic. I love how it tries to sort of be flexible. It's like if I think we can fix this, if you had a thing that is a string, but in the string it really is parsable to a number, and it's supposed to be a number, I'll just go ahead and do that type conversion for you. If not, I'll give you a decent error message. It's really really lovely.
Yeah. So if I'm working with APIs, I love Pydantic for that reason that you just outlined. But I'll often convert it to a data class or a Pydantic data class, so that I can say this is a relationship of data, and I can kind of shape how a user uses that relationship of data throughout the lifetime of the code.
Right. Yeah, it's an interesting tension on how much those models get used throughout all the tiers of your app and how much you want to keep them separate. Have you seen SQL Model, I believe it's called? That just came out?
I have not.
Okay, here we go. You probably heard of Fast API, right?
Yeah, of course.
Obviously, that's where Pydantic got, I think, its big boost. So Sebastian Ramirez came out a few days ago with this thing called SQL Model. And it already, I think it's less than a week old and has 4,000 GitHub stars, which is amazing. But basically, it's a merging of Pydantic and SQL Alchemy.
Oh, fantastic.
So it has the SQL Alchemy unit of work model, and it has all the SQL Alchemy stuff, but its models are actually Pydantic models.
Yeah, and I think this is just another illustration of why thinking about what types things are, even if you're not doing type annotations, why that's so important. It goes back to how do we build mental models? How do we build these these abstractions in our brain that we can rely upon as we work through our code base.
Yeah. I do think this is interesting in that you could use the same model at the data level, internal to your app, and then you could even use the API level. But there's also people are saying, but maybe that's not a good idea. Maybe you want to separate those in interesting ways for like one can change and the other doesn't have to change. But yeah, I see a lot of value to this thing. It looks exciting.
Yeah. And I mean, the answer to that is going to probably be, it depends. If your application needs them to be the same, law of least surprise, make them the same. If they have different reasons to change, this is something I see a lot too. We all get the dry principle, don't repeat yourself, ingrained in our head. And we think, oh, if source code looks the same, we must deduplicate it. But if that source code can change for different reasons, you're going to add more headaches by deduplicating it, because you're going to start adding special cases. Well, this thing needs to change, but the other thing doesn't. How do I reconcile that? Special cases. And soon you've become the very thing you've sworn to destroy as you build that out. It's just littered with special cases as you're trying to tie together two things that have two separate contexts. So, if you want to use something like SQL model for a API level and your internal data model, ask yourself, do these have different reasons for changing? Maybe in the future, and like a lot of this is just empathy for the future. When I talk about maintainable code, robust code, you have to have empathy for those future maintainers. Put yourself in their shoes. Are they going to want to migrate at some time and maybe change the API that they present to customers or users or other developers? Do you want to change your database at the same time? If so, keep them together. If you want to keep that separate so that you have certain migration paths, maybe you keep them separate. And so it's going to depend case by case. But again, everything comes down to those first principles of what are you communicating with your intent when you make that decision in your code.
Yeah. Well, and you're also, like we've touched on, you're building different things at different times under different constraints. Are you building Instagram's API, which millions of people and apps are using? Or are you building something really quick so you can get that app to work for marketing for the next thing for the week, right?
Yeah.
If it's the second one, then you don't want to worry about too much abstraction, and you just want to go like, I just need these to be in sync. The data goes here. We're going to send over the API. We're going to be good, right? This is going to fly. On the other hand, if you're building something incredibly consumed and long-lived, then maybe you have different design patterns and care about it.
And I think it's important to think about organizational boundaries. Is the users, the consumers, the actors in your use cases, is there an organizational boundary separating them? In the Instagram case, the people who are going to be using my API, I have no control over in my organization. It's general public as far as I'm concerned. If it's just someone on my team using it, we can work through, okay, I'm changing this API. Let me help you through that. But if it's someone outside your team or outside your organization, you're going to have a backwards compatibility to think about. You're going to have all these vast amount of things that people are going to complain about. And you need to think about that and say, okay, can I make these changes? And is it good for my user base? Even though I can't control them. The best I can do is entice them, but you'll never be able to force someone to use something they don't want to if you don't have that control over them. That's why we have open source forks.
Yeah, absolutely. So one of the ideas that I think comes up in this whole story, and you talk a lot about like inheritance, both inheritance in terms of class hierarchies and even multiple inheritance, but also maybe the more traditional interface style with protocols, just so that you can express type stuff separately, right? In interesting ways without coming up with inheritance beasts and whatnot.
Yeah.
So one thing I did want to give people a quick shout out. So we've all heard of solid principles, right? And I really enjoyed the solid principles, and I thought they were super interesting. I still do. I think they're pretty great. I recently came across a presentation, and I encountered over on Richard Campbell's show, .NET Rocks, which I know people probably don't care about .NET, but they actually talked about this thing called Cupid, which is an alternative to Solid.
I might have to go check that out.
And it was super. It has nothing to do with .NET. It's just like software in general, patterns. Like what do we know now, 20 years later, that doesn't necessarily make so much sense for Solid? And what is the alternative? And he has this really cute name. So as people are thinking about maybe those kind of levels, like that's a pretty interesting to check out.
Yeah, and I like thinking of Solid again. Going back to first principles, there are things that I like about Solid. There are things that I also think get a bad rep because they're associated with heavy OO code bases that have class hierarchies that are just unmanageable.
Probably multiple templates in there somehow as well.
And all sorts and we've kind of grouped these things together. So an example, like one of the most misunderstood ones, in my opinion, is the Liskov substitution principle for the Solid principles. Yeah. And like it applies when you're doing duck typing in Python, which has nothing to do with class hierarchies. It doesn't have anything to do with, interfaces or things like that. It's a term about substitutability. And so when we talk about duck typing in Python, it's, multiple types can represent some behavior. Maybe they support an addition method and a subtraction method. Can they be substituted into this function that's expecting addition and subtraction?
Right.
And so we think about
I do addition and subtraction on dates and times. Another might do it on like imaginary numbers. But the concept of adding and subtracting things, you can read that, right? Something like that.
And so things like Liskov substitutability principle talks about how do you think about substitutability from your requirements and from your behaviors, and you can get value from that without ever touching a class. So I think all too often we lump those Solid principles to a strict OO of the 90s or the noughts and think that they aren't as useful. I'm gonna have to check out Cupid and see how that's changed as well. I would expect that a lot of the same first principles are true, but they've kind of reframed it in a way that is more applicable to how we program today.
Yeah. I don't remember all the details exactly. So, but yeah, something roughly along those lines. I think that makes sense. So one thing I do also want to just sort of get your thoughts on before we leave it completely in the dust is you talked about a lot of times you've got a dictionary and it's supposed to represent some stuff. Maybe it's a response from an API where it says, here was what you requested, here was the status code, here's what the cloud cost of that is, and here's like the, something that looks like that. Maybe doesn't make sense as a dictionary, maybe gets moved into like a Pydantic model or something like that, right? But the other one is, I have 10,000 users and I want to put their email address as the key and their user object as the value. And given an email address, I want to know super fast which user is that, or do I have that user at all? In that case, a dictionary makes a lot of sense.
Absolutely.
But there's a super big difference to say the keys represent like the same thing across different results, whereas the same data structure, a dictionary, represents this heterogeneous, like not really a class, but kind of a class. How do you position those so that beginners understand that those are completely unrelated things that need to be thought about separately, but they kind of appear the same in code? Because when I'm talking to people about dictionaries and I'm teaching, they're like, oh, well, why would you use a dictionary here? Because over here you were doing it this other way, but now it's like a database. Like, what are you doing with it? This is weird. Why are they the same but different?
So here's how I explain. So for the key mapping value, I would say there's a few use cases you're going to have. You're going to either be iterating over the dictionary to do something on every element, or you're going to be looking up a specific element, and that lookup is dynamic. You're typically passing in some value. Maybe it's a variable that contains the email address in your example. For something like an API response, something that might be more heterogeneous, something that should be a data class or a Pydantic model or what have you, you typically aren't iterating over every key. You're looking up specific keys, but it's statically indexed, meaning you're passing in string literals between the square brackets. This is the key I want in this circumstance, the name, the age, the date of birth.
Right.
And so you're looking up specific fields and you're building a relationship between different key value pairs. A name, age, and date of birth is a relationship called person. With your dictionary, with your mapping, your key value mapping, there's no relationship between email 1 to user object 1 and email 2 to user object 2. The relationship is just from key to value. And that's typically what I explain to people trying to discern the difference.
That's a really interesting way to think about it. Because you will almost always use static literal strings when it's the heterogeneous API response style. And you will almost never do that. Like, why would you say, quote, type in the email address? You would just have that object. You wouldn't need to type in, like, you would just never create that structure in the first place, which I think is really interesting. So if you're you're dynamically passing in the keys. It's probably all the same object, but different ones of them, as opposed to an API response.
And I think that's the heart of why I really wanted to write about robust Python. So I've been programming for a while now, and I make a lot of decisions as a senior engineer. And I really started to step back and ask myself, why do I make these decisions?
Yeah.
Why do I choose a dictionary over a data class? Why do I choose a class over a data class? Why do I choose an acceptance test over a unit test? Why do I choose to do a plugin here, but a dependency injection somewhere else? And I just wanted to start documenting, here's why I make the decisions I do. Here's what intent I'm trying to communicate through, in the hopes that we start normalizing that conversation more in our field. Why are we doing the things we do? Because as a beginner, it's frustrating. Oh, why you use a dictionary here? Why? Use a set
How
here.
did you
Why?
ever know to do that? Yeah.
Yeah. And so I wanted to really capture, again, I've said it a lot, the first principle is why am I doing the things I'm doing? What are the things that I often give as advice to junior programmers and intermediate programmers too, and senior programmers? It was really enlightening for me to really step back and try to dissect why I do the things I do in Python and come up with, here are the valid engineering reasons behind it, and try to frame that in terms of maintainability.
Yeah, I think that's very valuable. I think it'll help people learn, because it's not enough to see it by example. You're like, well, these both kind of work. It's like, yeah, but they mean something different. They totally communicate something different. A couple of thoughts from the live stream I want to share. Kim Van Wyck out there says fantastic advice about having too much configurability. Far too often, I prematurely dedupe two similar blocks of code and then find myself adding special cases I wouldn't need. Yeah, that sounds like what you were saying as well.
Yeah. And so what I would say is there's a difference between policies and mechanisms. The policies are your business logic, and the mechanisms are how you go do something. Logging module in Python is fantastic for this. The logger module doesn't care what you're logging, how you're logging it, when you're logging it. It's just the mechanism.
To dev null, who cares?
Yeah.
It's all the same.
But what you're logging is your policies. And so very often I try to find a way to say, okay, how do I make my mechanisms deduplicated? Because those are what have reuse. My business rules are going to change. They're going to change for different reasons. I want to make that simple to define business rules, but keep the mechanisms reusable. You want to be able to compose those mechanisms together.
Yeah, that's a very interesting point. Also on the live stream, Mr. Hypermagnetic says, is it faster to look up a user or whatever from a dictionary rather than iterating over a list? And I think, boy, oh boy, if you've been down that path, you know there's a difference.
This is coming from an advice from a C++ programmer who really cared about performance. Measure it. Yeah. Use cases can be surprising. If there are times where a contiguous block of memory with a binary search is faster than a dictionary lookup, but you will not know until you measure it. There are also things that need to be fast in your program, and there are many things that don't need to be fast in your program. I think it's important being aware of which one those are. You don't want to not to sound cliched, the whole premature optimization is the root of all evil. Breaking that down a bit, you don't want to just optimize everything, because it takes time to optimize things, and it can obfuscate your code to optimize. Why am I iterating over a list when a dictionary lookup can be just as useful? If you measure the parts that need to be fast and you say, this is slow and this way is faster, as long as you have a comment and a good commit message that says why you're doing the slightly obfuscated way or breaking that law of least surprise, as long as you have those breadcrumbs for someone to follow and go, oh, it's for speed, this is the critical performance loop of my application. Maybe it's the web request handler or something in a database engine. You want to give those breadcrumbs so people can learn why you made the choices you did. The last thing you want is someone in 5 years to say, oh, they were iterating over lists because they don't know that a dictionary exists. Let me go change that and slow down your app. But without that measurement, without that data, it's a fruitless endeavor, in my opinion.
Yeah. I mean, for a lot of data in general, a dictionary lookup would be a lot faster. But if what you have to do is every time create the dictionary and then do the lookup, it probably that act of creating the dictionary erases the speed up of, because you would have you're kind of looping it over anyway, right? So it depends, but if it's
don't take what I've said as prescriptive. Measure.
Exactly.
Measure.
Yeah, absolutely.
And invoking just your command line application with -mc profile is super illuminating. How long have I spent in a function? How many times did I call this function? Where's most of my execution time spending? And it might be that the bottleneck you think you have is somewhere else completely.
Well, yeah, that's actually a really important point as well. If you do that C profile and you find you're spending 5% of your time in that part you're trying to optimize, if you could make it go to 0, it's still going to be 95%
Yeah.
as fast, right?
So-
So if it might be able to be sped up significantly, but it might not actually be germane to making your program feel any faster, because it's like optimizing nothing.
Yeah.
Basically.
And I don't want to misrepresent. To go back to the question on the live stream, typically a dictionary lookup will be faster than iterating over a list. I expect that most of the time. I would not rely on that all of the time, which is why I advocate measuring.
Yeah, measuring. I've definitely been in the place where I'm like, oh, this 6,000 line super complicated thing that is hard to understand and work on, this is where it's slow. And no, it was just some other like wrong data structure and some other very simple part. But if I didn't measure, I would have gone and tried to rewrite the part I was like barely understanding and would have probably broken it and still would have been slow.
Yeah. I forget who mentioned it, but there's the order of writing things is you make it correct so that, and you have tests around it so that you know that it stays correct. You then work on making it clear, and then you make it fast if it needs to be. And that last part is optional based on, is this actually slowing me down? Is there business value I'm losing because this is slow? Yeah. If it, there's certain things I work with. We're publishing something once a day. If something takes another 5 minutes, I don't really care. Like my time is spent better on focusing on parallelization or things of that nature. And so it's just really understanding why things are slowing down and where. So this is a little bit of a tangent of robust Python, but it's an interesting question to bring up nonetheless.
Well, is that 5 minutes? Are you waiting in that 5 minutes, or is that you kick it off and you go? Yeah, exactly. Then you probably don't care at all. But speaking of time, I'm sure there are a ton of people listening that are like, I would love to take some of these ideas, maybe using MyPy or putting more types or looking at stuff like Pydantic and so on. But at the same time, there's a lot of pressure on me to just, from the time I receive the request to get some feature done till the feature is done. And the people making that request, managers, business owners, clients, whatever, they don't care that much about robust Python. No. They want minimum input of money and time for output of features. But anyone who has done that for any extended period of time knows that that is a net negative. Yes. So how do you address that? I'll give you some thoughts of what I've done, but how do you address that for people who
the way
are receiving that?
I want to frame the conversation first of it is your duty to deliver value as quickly as you can. It is also your duty to make it so that your maintainers can deliver value at the same speed. So if you're delivering value today, but hindering your ability to deliver a month, 3 months from now, that's a problem. Now, I'm not saying jeopardize your MVP or go-to market, but making sure that the business people understand, I can do this. I'm not going to be able to do this again. The other part that I say that is just practice. Practice with these sort of concepts and apply them in small places. You can do things incrementally. Maybe there's a couple hundred lines of a library you have. Just write type annotations for that or make it more extensible. Find small little wins here and there. And as you keep working at it, just as Boy Scout rule, leave the code base cleaner than you found it. So if I'm going into something and say, you know what, these assumptions don't hold up anymore, I can't fix it all right now, but I can do one incremental step that makes it easier the next time I'm in here. I take those little bites over time and slowly morph into something that's like, okay, as we start slowing down delivery, I'm starting to make those improvements, and then we start speeding up back again. Because there is a real tension between deliver it now and making sure that you are going to be able to deliver hastily in the future. And by no means am I advocating gold plating where, make everything maintainable now, because there's typically a business behind this and you don't want the business to fail. You need to be able to ship early and often. And it's that often part that is often the tricky part.
It is tricky.
Practice,
also,
practice, and target where you're applying these ideas.
You have tools to make it. You don't have to put all that flexibility in there first, right? You write it one way, you get it out, but then you have refactoring tools, you have continuous integration, you have things that allow you to make those changes as long as you keep using them and as long as the code doesn't get too bad.
Yep. And here's one of the things I've always liked seeing. I forget who said this. There's a great quote. It's like, to make a hard change, first make the hard change easy. That's the hard part, and then go make the easy change.
Yeah.
When you see, like, a lot of teams do some sort of estimation of their stories, how big will this effort take? If you see consistently high estimates, this is always a large. We're always doing larges and extra larges. Ask yourself, what would it take to make this a small? Some teams use Fibonacci numbers. Like, if this is an 8, what would it take for me to make this a 3? And some of your listeners may be like, what are you talking about? But estimation, we're estimating effort.
Right. Yeah. Traditionally, way back in the day, people used to estimate in hours. How many hours is this going to take you? And it's like, that is a granularity that we don't have. Like, I can't tell you, is it 17 or 18 hours? That doesn't, I can tell you, is it 2 hours or 2 days, but I can't tell you whether it's 17 hours.
And so when you get large estimates again and again, ask yourself, are these estimates because of necessary complexity that's inherent to my domain, or is it accidental complexity that is built up over time? I have to so necessary complexity is, of the deep workings of a neural net or flight controller software. Like, these are inherently hard problems. I can't make that simpler, not without making a whole lot of money revamping an industry. But things like
maybe tax preparation, right? Like, there's a minimum set of complexity to just figure out what that answer is, because the rules are complex.
Yeah. But let's take that tax. If I have to, maybe add a new rule, and it's just a simple multiplication somewhere, I shouldn't have to add 20 to 30 files of changes just to implement that one thing, because it's going to happen again and again and again. Yeah. And so you look for these common cases, you say, we keep saying this is a large effort. How do I make that smaller? And then you say, if we just restructured things here, you often find that the same amount of effort to go make that hard change easy will pay off in 1 to 2 cycles of, like, okay, now that we're doing this again and again and again, like, yes, I took an extra day longer or week longer. And again, be mindful of your schedules. I'm not saying slip schedules intentionally, but find that wiggle room where you can. Band together with your team and find those areas. Oh, this is a place that we can get some gains back. I often like to set junior engineers on the team at these sort of tasks. They get more familiar with the code. They often don't have as many responsibilities as a senior engineer. And they just get that understanding. And they feel like, I've done something that really, really matters.
I really send them in on a cleanup job.
Yeah, and that has worked wonders for me as well. And, like, it's just worked. It's a win-win. And then you're delivering those features, those same things you're doing again and again at a much greater speed, and that saves you time to go do the next thing that you have to do.
Yeah, my approach to this, it only works with certain groups of stakeholders, I suppose. But when somebody would ask me, how long does this feature take? It wasn't like, well, here's the essence of the feature. Like, it will work and you can click the button. Here's how much it'll take to add error handling. Here's how much it'll take to add logging. Here's how much it'll add to make that work in continuous integration and have tests. And here's how much we got to do to, like, not add technical debt while adding this feature, right? Yeah. Instead of presenting like, well, here's your menu. Well, all I want's the feature. Just give me the feature, right? I just say, okay, well, if the feature is 3 hours, the other 2 hours, like 5 hours. It's going to take me 5 hours or whatever, like, metric used. That is what delivering it means in a professional setting, is that it is done, not that it's minimal path with 0 errors and 0 bad data will execute, right? They're not the same. Yeah, but it's easy to get sucked into the minimum. How quick can I do this? I bet I can do it in an hour if I really fly, right?
Yeah, and I think that's a trap we often fall into. Like, we're, as engineers, it's our responsibility to provide accurate estimates for what's best for the business. And, like, if you say, I can do this without tests, What you're really telling people are, I can do it, but I can't guarantee it will keep working after I deploy it because I will have no way of knowing. I've removed that visibility of tests to tell me, oh, this important thing that you really wanted now, no idea if it's working now. Sorry. And like, once you start framing it like that, people go, okay, yeah, okay, let's see what we can do. And you might need to have some hard conversations with the people who manage this. It might be, we need more headcount. We can't take as many projects. We can't take this much complexity. Maybe a worldwide pandemic is happening and we've been severely impacted. And I mean, to some degree, you can't fix poor management of something, but you can coach your way up to try to get out of that. Some people are very receptive to that. Some people are not. And in the places that aren't, I mean, you have to ask yourself, is this something that I'm going to live with, or is this something that bothers me and I need to think about other things?
Yeah. Well, I think you're probably in a pretty good space if you're making that clear to people. Yeah. So I think if you're proposing a feature or how long will it take to do this feature, then you just include what that means for a feature to be done. Yeah. Like it's not like zero bad data and it works sometimes. Like it works for real. The harder story is we've gotten into a bad place. We need to not add features and just refactor improvement. Like that is a different story than like, what does done mean?
And that's a really tough one because if I'm a business person, I'm never going to say, yes, please stop feature delivery and making money for us to go build the same thing we already have. Like that's a tough sell to a business. And I really think just an incremental approach. And again, I mentioned earlier, targeting strategically. What are your most used libraries or parts of code? What are the areas with the highest bug count? Put data to that. Hey, we've had 5 customer complaints about a crash in their system. They're linked to this one piece. If we start doing this, we save X amount of money and we would have kept that one customer. Yeah, that's the sort of thing that speaks when you're getting against those somewhat unrealistic business pressures. You have to speak on their level. And what I'm saying is a little wrong because it's not an us versus them type mentality. You're in this together. They feel us versus them at sometimes, but you need to work together, make them understand here are the business implications of the choices we're making. Yeah,
exactly. I mean, you're the engineer and they're the business people, but you got to just put the situation in terms that they appreciate and they can decide if it makes sense for them.
Yep.
I would also add, people out there listening, that if the answer is almost never can we clean up technical debt and make this better, you probably will end up with a team over time who is full of people who don't care about erasing technical debt and making it better. And it's only just going to get worse and worse in combinatorial ways. It's not where the top engineers want to be. And they don't get excited about coming to work where they have to like, sneak in something that's unreliable and cram new features into broken, ugly code.
And something I've learned over a long time programming is almost every technical solution, there's a people or process problem at the root of it. Like there's a lot of things that we think, oh, code can solve this. If I just refactor this, everything will be great. But there's a people aspect of this. And I'm not putting down those people. Like everyone around you is this living, breathing human being. They all have their own hopes, their own dreams, their own obstacles, their own places in life. And we have to recognize that sometimes. Sometimes you have to work with the people in order to solve that technical problem.
Yeah, absolutely. So much for the mythos of the software engineer in the basement by themselves, huh?
I think that stereotype is long dead for the most part.
I agree. All right. Well, we could go on and on, but I think we're out of time. So thanks for all your thoughts on this. And the book's interesting. We'll talk more about it in a second. But before we do, if you're going to write some of this code, work on some of these ideas, what editor are you up to?
I use VS Code because I still jump between languages quite a bit, and I like the flexibility of that. For a onesie twosie, I'll use Vim.
Cool. Then notable PyPI package?
I'm going to call it Stevedore because it's a package used for plugins, doing plugin development. I think it's really neat how it uses the packages entry points so that you can deploy plugins as separate pip installable packages. Just something I wish more people knew about.
That's awesome. Yeah, one of the things we didn't cover, but is also part of this robust story that you tell is about extensibility, about plugins, about all those kinds of things, right?
Yeah, and that just goes back to making the common cases simple. If you're doing something again and again and again, make it easy for people to do that. And extensible code is a way to do that.
Yeah, like that tax example, right? If you could plug in the formulas that are applied in this place, and then like you just add it in, and maybe it just picks it up and goes, that would be ideal. Yeah. All right, awesome. Good recommendation, one that I had not heard of. All right, so people are interested in this idea. I assume that they can check out your book. Maybe tell people about that real quick, and then like what else would you provide as resources or places to get started?
Yeah, I think just talking to senior members on your team, talking to junior members on your team, learning how people use the code around you, keeping an ear for your stakeholders, your code developers. Think about the code you write. Think about the implications it has. And just listen. Most of this is empathy. I thought I was writing a technical book. I wrote a book about empathy instead and just didn't know it. Put yourself in other people's shoes and think about how they're going to perceive your code a month from now, a year from now, 5 years from now. Again, a lot of talks that you'll see at something like PyCon or the other Python conferences, you'll see these nuggets of truth throughout them. Ask yourself, why are they making the decisions they do? And see if you can really understand the root cause of why they're using this feature. Especially as new features come out with Python.
Yeah. Well, a lot of great ideas in here, and I had a fun time talking about them.
Me too.
Yeah, thanks for being here, Pat.
Thank you so much.
You're welcome. Bye.
Bye.
Bye, everyone in the live stream. Thanks for being here, or thanks for watching.